question is to use the DH convention to solve the Stanford manipulator. We have seen the Stanford manipulator from the first lecture. We have seen the photo. From the Stanford manipulator, we can see that the base right here, we have a RRP. And then right here, now we're familiar with this part, so that is a spherical wrist. And right here we have the wrist center, okay? To do the analysis of this manipulator, and which it already gave us the complete manipulator, and it has 1, 2, 3, 4, 5, 6. It has 6 joints. So the step 1 of DH convention is that we need to find the 4 parameters for every step. Okay, so since we have 6 joints, and means we need to do 6 analysis, so I write as 1, 2, 3, 4, 5, 6. And again, the 1 means it's frame 0 to frame 1, and frame 1 to frame 2, and frame 2 to frame 3, and frame 3 to frame 4, and frame 4 to frame 5, and 5 to 6. Okay, so these are the coordinate frame transformation. In each step, we need to do the analysis to find out the AI, alpha I, and DI, and theta I. So AI means the distance on the xi axis between zi minus 1 and zi. So now we start to do the analysis row by row. The first one is from frame 0 to frame 1. Okay, so it already gave us this is Z0. This is Z0 and the Z0 and Z1 the frame. Okay, so now let's start to do the analysis for each transformation. So the first transformation is from frame 0 to frame 1. And in this drawing, this diagram, it tells us this is C0. By right-hand rule, we can quickly identify this is X0 and this is Y0. Okay, because the frame 0 and frame 1, they have the same origin, so it doesn't draw the X0 and X0 and Y0 to make it easier to see, okay? But anyway, from the right-hand rule, we can quickly identify which is X0 and Y0. So why they have the same origin if we consider the real robotic manipulator? And it means that these two servo, they're at the same spot. Although there could be a little bit offset, or there's no offset. Okay, so it means these two servos, they have the same position. Okay, so if that is the case, and then these two frames need to have the same origin, the same location, because they're each of the Z axes is corresponding to one servo, one rotation. Okay, so these two servos are together. Means we have the two frames at the same location, and then we can start to find out these 4 parameters because they are having the same origin. So my AI equals to 0 and DI equals to 0. And how about alpha I? Alpha I is the rotation from Z0 to Z1 in this case, and again we need to use right-hand rule to find out what is positive. Okay, so if you want to use your right-hand rule, and first of all, you need to use your right hand, and then your thumb is pointing to X1 direction. And so, this is going to be my right hand, and these are the 4 fingers. And the 4 fingers is pointing to the positive rotation direction. Okay, so if we rotate around this direction, that is positive. Okay, so it means if we want to rotate from Z0 to Z1, and we need to go this angle. Okay, so that is this angle. So that is 270. So if this is 270, and it means you can say 270, or that is equivalent to negative 90. Means if you go this side, and that is opposite to the positive sign, and you go 90, but that is opposite. Okay. And theta I, again, at every step, there must be a joint variable. And now the first joint is a revolute joint, and we're doing the analysis of this one, right? And so that the rotation is, it is a revolute joint, so the joint variable is theta 1. Okay. And the second transformation is from frame 1 to frame 2. And here, okay, so on the diagram, it doesn't draw the geometry of the manipulator, but this is a prismatic joint, this is a revolute joint, so it's impossible that they have the same spot. So on the real robotic manipulator, there must be a link between this servo and this prismatic joint. So I gave this link, this geometry as D2, and say if you have the real manipulator, you can use a ruler to measure what is D2. Okay, and then what is AI? And AI is, we measure the distance between Z1 to Z2 on the X2 axis. So this is my X2 axis, and the projection of Z1 to that is here, and Z2 is here. Okay, so that is AI is 0. And alpha I means the rotation around X2 axis. Okay, so my thumb is pointing to X2, and means this rotation is positive. And here I have my Z1, which is pointing to this direction, and this is my Z2. So if we want to rotate from Z1 to Z2, okay, so this axis is Z1, okay, from Z1 direction to Z2 direction, okay, so that is positive 90. And DI means along Z1, it means the distance between the origin O1 to the intersection of Z1 and X2. Z1 and X2, so the intersection is here, this point, which is O2. So the distance between O1 and O2 is DI, so that is D2, which is the geometry, the length of the link. And now this is a revolute joint again, so the joint variable must be a theta or a alpha in some cases, and in this case it's theta. So that is theta 2. Okay, so normally, if it is a prismatic joint, normally we have the theta, the joint variable, as the theta I. That is because when we define the frame of a joint, we always give the Z as the rotation axis. So that means your theta, by definition, theta means the rotation from xi minus 1 to xi along zi minus 1, along zi minus 1. So this is the rotation axis. So normally, if it is a prismatic joint, the theta I is the joint variable. Okay, so the next one is the frame 2 to frame 3, and frame 3 and frame 4, 5, they have the same location, means this is the wrist center, and means here we have a spherical wrist. If it is ideal spherical wrist, means there's no offset, means the 3 servos, they have the same spot, they have the same rotating center. Okay, although when you really build it, in some cases, you may have a little bit offset. Okay, so here we have the frame 2, and here we have the frame 3. And frame 3 has the axis, which is this direction. So we start to do the analysis. AI, I have my AI means the projection to the X. Oh, okay, so seems like the Z4 is here, Z3 here, so the frame 3, 5, and 6, they have the same X and the same Z, okay? And so here I have my frame 2, and here I have my frame 3, and the projection to X3 axis and then my z2 and z3, they have the same spot on x3 axis. So ai is 0. And alpha I means we use our right hand, and the thumb is pointing to the xi direction, and then we take a look at, this is my z2 and z3, they're the same axis, so this is 0. Okay, and my alpha is 0. And my theta I means the rotation from x2 to x3 along z2 axis. And this is a prismatic joint. This is a prismatic joint. So it means that the d3 is my joint variable. So here I need to have my d3, and this d3 is changing. Although this d3 could be a real length plus the prismatic motion of this prismatic actuator. That is possible. And or the actuator, for some cases, for example, here we have the linear actuator, and this whole prismatic joint, it can slide from the starting point all the way to here. So the sliding can happening from the beginning of the end of this link. Okay, so in that case, it means d3 is the whole translational motion direction. So d3 is my joint variable. And how about theta I? Theta I, in this case, is not a revolute joint, so we need to use the geometry to find out what is theta I. Here, x2 and x3, they're parallel, so that is 0. Okay, the next one is frame 3 to frame 4. Here I have my frame 3, and here I have my frame 4. Okay, so they're at the same spot. It means my AI is 0, my DI is 0. But there is an orientation because of the revolute joint. Okay, so here, the first revolute joint, that is theta 4. So here we have theta 4 as the joint variable. And then we take a look at alpha I. Alpha I is the rotation around x4 axis from z3 to z4. Okay, so again, here I'm considering the x4 axis. So my x4 axis, where is my x4 axis? Okay, so if this is z4, so what is alpha I? What is alpha I in this case? Alpha I means we point to the x4 and the rotation from z3 to z4. Okay, so here all these frames, they share the same x, and which is already marked here. So then I have my right hand and pointing to the x4 direction, and then I need to consider the rotation from z3 to z4. z3 to z4, it means this direction is positive. Okay, this direction is positive, and then I have the rotation from z3 to z4, and seems like we need 270 to rotate the z3 to z4. So my alpha I is negative 90 in this case. And the next transformation is from frame 4 to frame 5. Okay, so again, they have the same, they're having the same origin, so AI is 0, DI is 0, and the rotation is along Z4 axis, so we have our theta 5 star as the theta I, which is the joint variable. And my alpha I is, again, I'm using the same axis, so that means this rotation is positive. Now we're considering, because they have the same axes, so now I'm considering the rotation from Z4 to Z5, and here I have my Z4 and Z5, and it goes this direction. Okay, so that is positive 90. Okay, and the last one is from the frame A5 to frame 6. This is Z6, and we use Z6 and as the same axis as the spherical wrist, so that is easier to do the analysis. So it means that we define this. Okay, so let me just draw it in the center of the end effector. Okay, so here we have the Z6, and we have the frame 6 that is fully parallel to the frame 5. Okay, so now we have the X6 and Y6. So the frame 6 is for the end effector, and from the spherical wrist center to the end effector, the distance is D6. So it means that when we want to define the last row, that is the transformation between the robotic manipulator and the end tooling. Okay, so this is the A6. Okay, and the method to find the 4 parameters is the same. Since these 2 frames are parallel, so then we know that we do not have A0, so it means A0 is AI is 0, and alpha I is 0, okay, because these 2 are fully parallel. And here from the DI means from the O5 to the intersection of Z5 and X6, so which means it's here, so this distance is D6. And the rotation, because these 2 are parallel, but this joint that determines the frame 6, that is a rotation. So we have the theta 6 star right here. Okay, so now we can see that the first step is to find the 4 parameters. And then again, the second step is to use the AI matrix to find out A1. Now we have A1 to A6. Okay, so A1, if plug in these 4 numbers, 3 are constant and 1 is the changing variable. So I can quickly generate this A1 matrix. And again, the last row is 0, 0, 0, 1, and I have this thing as C1. C1 means cosine theta 1, and 0, negative S1, 0, because these 2 are 0, so we have 0, 0. And this is S1, 0, C1, and 0, negative 1, 0. You can try to plug in these 0, negative 90 degree, and 0, so that you will have the same A1 matrix. Okay, and then my A2, based on my calculation, and the only okay, so my A2 matrix, that is based on my calculation, with these four parameters, that is C2, 0, S2, 0, S2, 0, negative C2, 0, 0, 1, 0, D2, and here we have 0, 0, 0, 1. Okay, and I calculate my A3. My A3 is pretty simple because my A3 I have these 3 zeros, so that is pretty simple. So I have my A3 is 0, 0, 0, 1 and 1, 1, 1, 0, 0, 0, 0, 0, 0, and this is 0, 0, D3. Okay, and my A4, based on my calculation, that is C4, S4, 0, and the last row is 0, 0, 0, 1, and here is 0, 0, negative 1, and this is negative S4, and C4, 0, and 0, 0, 0. And my A5 is C5, S6, C5, S5, and the 0, and we have 0, 0, -1, and S5, C5, 0, 0, 0, 0, 0, 0, 0, 1. And my A6 is C6, S6, 0, 0, 0, 0, 1, and this is negative S6, C6, 0, and here I have 0, 0, 1, and this is 0, 0, D6. Calculate T6, 0. It means the final position and orientation of the end effector with the reference 0, so I have that as A1 times A2 all the way times A6. Okay, so it means each A is a transformation between two frames, so that the last row must be 0, 0, 0, 1, and the thing that is 6 matrix multiplication, you can use MATLAB to quickly do that. And here, if we want to do hand multiplication, hand calculation, that is possible too, and it means that is these 6 matrices multiplication. So this is my final result. Okay, so the last question is an over homework question. So now for this question we have 1, 2, 3, 4. So it means we have 4 joints. Now I have 1, 2, 3, 4, and this means the frame 0 to frame 1, frame 1 to frame 2, and frame 2 to frame 3, and frame 3 to frame 4. And I have the step 1 is to find out the 4 parameters, which are AI, alpha I, DI, and theta I. So then from what we have talked about from the previous examples, I believe you can quickly find out these 4 parameters for each step. And then the step 2 is because there are 4 joints, so we have A1 all the way to A4. And then we can quickly find out T40. Okay, so this is our homework question. So next lecture, we will talk about inverse kinematics. So I will stop here for today.